Hello and welcome back. Today we start talking about artificial lift methods, beginning with gas lift. This method is a logical follow-up to the natural lift flow production, which is using reservoir energy is no more sufficient to lift the liquid up to the surface. We get the extra energy from the compressed associated gas or air or natural gas at its normal pressure, in which case no compressor is used. Gas lift is efficient, relatively inexpensive, fail-safe as there are no moving parts involved, and simple to use and control. For the annulus, gas is supplied through special mandrels into the production tubing. There it goes up carrying the liquid alone. Reduced hydrostatic pressure serves two purposes. First, it causes gas bubbles to expand, thus pushing the liquid up to the wellhead, and then reduced bottom hole pressure allows fluid inflow from the reservoir. We already mentioned that compressors may or may not be used for gas lift. Compressors are required when we need high pressure to pump the working agent into the well. Also, we can use natural gas from every pressed gas reservoir as our working agent. In this case, we won't be needing compressors. Gas lift may be normal, then a single tubing string is lowered into the well, or dual, then two tubing strings are used. In both cases, the annular space is used for gas injection, and tubing string lead the gas oil mixture up to the surface. Normal gas lift is more economical, but it will not allow sand removal, so it is used in wells with zero sand and water production. Dual gas lift uses small diameter production tubing, which ensures high lifting speed and allows for water and sand removal. Besides, dual gas lift provides more steady pressure and fluid flow, which reduces the working agent consumption. To save on metal, sometimes people use a dual lift system where the upper string is completed with lesser diameter pipes called the liner. Gas lift has the following advantages. All the equipment is installed on the surface and easily accessed. Simple design, high production capacity, up to 1,800 tons a day, regardless of well depth and production tubing diameter. Easy production rate control by simply adjusting gas injection, good efficiency for wells with water and sand production. Well surveys can be run easily. Yet, gas lift has certain disadvantages. There they are. Pipes need to be replaced regularly, especially in wells with high sand and water content. Low performance coefficient, often below 5% at low dynamic levels. High initial expenses associated with building compressor plants, gas regulation stations, and gas pipelines. High electricity consumptions per 1 ton of oil produced at low production wells with low dynamic levels. However, operating expenses of gas lift are still lower, so it is widely used, especially in cases when pumping operations are complicated by high liquid temperature, high content of gas, sand, paraffin, and salt, as well as in deviated wells. Gas lift efficiency depends on mixture viscosity and velocity, wellhead pressure, and working agent pressure. Wellhead of a gas lift well is equipped with a conventional Christmas tree. Its operating pressure should be equal to or above maximum pressure expected at the wellhead. Because of gas involved, in winter the equipment should be heated using oily steam or hot water. Besides the Christmas tree, the following gas lift equipment is installed on the surface: working agent source, pipelines, gas regulation batteries. The following equipment is installed inside the well: production tubing, packers. These can be installed at the lower end of production tubing for fluid loss control and steady operation. Kick-off and chamber valves. Kick-off valves are required for gradual bubbling up of the liquid at the start of operation, and chambering valves are used to control gas cutting during the operation. Now you know about gas lift, and we can move on to pumps. See you!